Hello and welcome everybody. Good morning, good afternoon, good evening to all of you, and specifically welcome to Will. Thank you for joining today. Good morning to you. Hi, Will.
Hey, Alex. Hey, everyone. Thanks for joining.
How are you doing today, Will?
Yeah, pretty good. It's quite cold here,
Hmm.
but I have the heat cranked up, so I'm getting by. Getting by. It's definitely still
That's good.
winter, though.
Yeah. Here is it was super windy over the weekend. So it's today was a sunny day, so it was actually quite nice. But you never know when it comes back again, the winter grip, and then you you realize, oh, I packed the wrong jacket today. So not out of the woods, for sure. Yeah. Hi Ajmal
Spread.
from India. Welcome. Let us know where you're watching this. If you're watching this live, it's always nice to hear from you and see where you all are joining us from. Um, yeah, let's dive in. I guess today we are gonna talk about the GraphQL Library 3.0 release. So it's a special release that has just gone gone live or was just released a few days ago actually. So very fresh, super hot off the virtual presses, if you will. So fresh to all of us. We have maybe I'll put that in here. We have a blog and where you can find out some more stuff. I'll post a link here that our colleague Daryl wrote, like a summary of what's going on. I guess we'll dive into that in today's session. So I'm not going to go too much into it, but I'll share the blog with you in chat, as well as this general link for all of you if you want to get going with it, get started with it, what to do, where to get it. But also, I don't know, maybe we start at top. What is GraphQL, and why should you use it together with Neo4j?
Yeah, for sure. So I think there there's kind of roughly, I guess, like three sections of what I wanted to cover today. One
Mm-hmm.
is digging into the new features in this 3.0 release of the Neo4j GraphQL library, but then kind of take a step back and talk about like, okay, well what is the Neo4j GraphQL library, and then dive into also some features that were not specific to the 3.0 release that came in the 2.x series, and dive into those and with a live coding example. So yeah, so taking a step back and talking about just GraphQL in general is a great place to start if you're not familiar. So GraphQL is a technology for building APIs. So really it's a specification for how to define data that's available in the API, and then a runtime for fulfilling requests to resolve this data. And so really we're not talking about querying a database directly. We're talking about building this API layer that sits between the client and the database, that allows you to implement things like custom business logic, authorization, things that you don't want to necessarily like expose your database directly for. And GraphQL has some really important characteristics that make it really compelling for developers to use. One is this idea of a strict type system. So we define as basically like the starting point when we're ready to build our GraphQL API. We define the types that are available. So what data is available, what fields are on these types, how are these types connected? That's where the graph part of GraphQL comes in, because we're describing some data graph, how all these entities, these types, these objects are connected, and then how we can query them. And then at query time, the client is kind of free to select some traversal through this data graph to say, okay, I'm rendering a view of a list of blog posts. I need information about the blog post. I need some information about the author to show, I don't know, maybe like their avatar or something like this. So there are some really compelling aspects to GraphQL, which we'll see as we dive into this. Now, GraphQL is not specific to Neo4j, but because Neo4j is a database, we often use databases as the backend for API applications that we're building. That's a common way that we expose our application data is through the API layer. So GraphQL, you can really implement a GraphQL API using any data layer. It's really data layer agnostic. But to make it easier to build GraphQL APIs with Neo4j, Neo4j has built the Neo4j GraphQL Library, which is an open source JavaScript library for building Node.js, so backend JavaScript GraphQL servers, which is what we're going to talk about today.
Cool. That sounds good. I think that's great to get everybody up to what we're doing, and I think particularly because there's an easy confusion. I think lots of people make the GraphQL think that is a query language to actually graph databases, or Neo4j in particular, which is I mean, you could think of it, right? If you read it, it sounds like graph query language. So well, query a graph. So sure, let's do that. But you know,
Yeah,
yeah.
yeah, that's a really good point. So, so the graph part of GraphQL comes in the connections in the objects that we define in our GraphQL schema. So if we're talking about a blog posts have authors. Those are two different types: blogs, authors, and there's some relationship that connects them. We represent that in GraphQL. And when we go to then build the backend for this, how we're going to store the data that backs our GraphQL API, we have a choice of how to do that. We can certainly use really any type of database, but if we aren't using a graph on the backend, like with Neo4j, we have this like mapping and translation layer. So with GraphQL, we're presenting data to the client as a graph, but then in the backend, if we're say maybe using like a relational database or a document database like Mongo or something like that, we then have to think about this like mapping and translation layer where we're thinking, okay, graphs on the client, but now we have to translate that into like documents and collections if we're dealing with a document database, or write some joins and think about that in terms of tables if we're dealing with a relational database. But one of the benefits of using a graph database like Neo4j as the backend for a GraphQL API is that we have graphs kind of throughout the stack, right? So we're treating application data as a graph for the clients to query with GraphQL. Then when it comes to implement the backend, we don't have this mapping and translation layer because we have a graph in the backend. So it's basically a one-to-one mapping of the data model that we have with GraphQL and the data model that we have with Neo4j. So intuitively, it makes a lot of sense. We don't have this mapping and translation layer. There's performance benefits. Graph databases are optimized for traversing this data graph, which the kind of nested queries that you have in GraphQL. So while GraphQL is data layer agnostic, I think there are huge advantages to using a graph database as the backend for a GraphQL API.
Cool. I think that thank you. That's very powerful message, and I think that's very very good for everybody that uses it, and that is wants to set up, like I said, like a stack. And if you think about using GraphQL, you should use a graph database alongside with it to make it just easier all the way. Cool. I think that's explaining what GraphQL is, and if you have any more questions, obviously chat is always open, so type them in. We'll have a look and see if we can find a time to answer those. So that's the open invitation all the time. If you have any other questions generally on this is the community is very friendly and very open. So we have a Discord server with a dedicated GraphQL channel, which is very active and very lively. So join us there, or go to community.neo4j.com, where you can always talk about anything Neo4j related, but also obviously the GraphQL library is there present as well. But yeah, Will, I'll stop sharing and enable your screen so we can dive into what you present had prepared. So let me, yeah.
Great.
That should work.
Cool. So, like I said, there's basically, like, I guess, three sections that I want to dig into. One is talking about the 3.0 release of the Neo4j GraphQL library and specific features there, but then also just in general, what is the Neo4j GraphQL library? How do I use it? Why do I use it? With an example. And then I want to take a look at some of the specific features that were introduced in the 2.x series, so in the releases leading up to the 3.0 release, that I think are particularly exciting and useful. And so specifically, these are things like the introspector, so being able to generate a GraphQL API from an existing Neo4j database. I want to look at being able to drive database constraints and indexes from GraphQL type definitions. This is really cool. And then also look at the aggregations that were introduced along the way. So those are the kind of roughly three, I don't know, segments that I hope we have time for. So as Alex said, like, as you have questions, please drop them in the chat. I can see the chat here, so definitely let us know as you have questions. That's kind of a big point of us wanting to do these live streams. Cool. So let's jump in. I'm going to use this blog post from Daryl that Alex, I think, shared the link to in the chat as kind of an outline here. Great. So this post was what, last Thursday, I think, is when the 3.0 release came out. So Daryl on the engineering team wrote this, which is a great summary of new features in the GraphQL library, what changed. With any major release, there are typically some breaking changes, so we'll definitely talk about those. But before we get into that, let's take a step back and talk about the Neo4j GraphQL library just in general, what it is, and let's see if we can write some code to spin up a GraphQL API. So we said that the Neo4j GraphQL library is this Node.js JavaScript package that makes it easier to build GraphQL APIs backed by Neo4j. So in this API layer that sits between the client and the database, that's where we pull in the GraphQL library. And basically what we do, we have a code example here, is we write some GraphQL type definitions that defines the data that we're working with. And that's basically it. We pass those type definitions to the Neo4j GraphQL library, which then generates a CRUD, so create, read, update, delete, GraphQL API with all the operations needed for creating nodes, creating relationships, querying those, updating and deleting. And then at query time, so for any arbitrary GraphQL request, the Neo4j GraphQL library is translating that into Cypher. Important to note, a single Cypher query, sending that to the database, which the database can then optimize and send back the data that is expected for the GraphQL request. So basically, all we really have to do is write the type definitions that define our data model, the data we want to work with, pass that to the Neo4j GraphQL library, and we have a fully functional CRUD GraphQL API. And as we'll see later on, if we already have an existing Neo4j database, we don't even need to write those type definitions. So we can also then add custom logic to our API using Cypher. So in this example, we've annotated the schema here with a Cypher schema directive. And we're basically saying that when we want to find similar movies, so we have the movie type here, we have a similar field, which is giving us a list of movies. And rather than just trying to follow a relationship in the database, execute this Cypher statement, which has some logic for generating like a recommendation. So it's looking at overlapping actors and directors to find similar movies. And we can use basically all the power of Cypher to add custom logic to our API. There's lots of other features, like we can also add authorization rules. So if we want to add a rule that says something like only authors of a blog post are able to update and delete it, we can add these rules with the auth GraphQL schema directive directly in our schema, which is super powerful. There's also a OGM, which allows us to, or object graph mapper, kind of like an ORM, but for graphs. The GraphQL OGM for Neo4j uses type definitions to define our models, and then we have a OGM object that we can then use programmatically to work with the database. And then lots of interesting features here, like cursor-based pagination and aggregations, things like that. So that's the general overview. Let's take a look at an example of how this works. So the first thing I'm going to do is spin up a Neo4j Aura database. So Aura is the Neo4j cloud service. Let's call this GraphQL 3.0.
And I put if you wanna at some point also try this at home, basically I'll put a link in chat so you can create your own Aura instance. It takes a bit, so maybe you are, I mean, try it out if you can follow Will, but but for later definitely.
Cool. So I clicked to start a free tier database. That I think that's really nice about Aura is we have a free tier. I don't have to put in a credit card. I can just start to spin up databases, and the free tier instances they're not a trial. So if you've used Neo4j Sandbox before, so Sandbox, those instances go away after a few days. You can extend them up to a week, but eventually they go away. The nice thing about free tier with Aura is that those stick around. So it's great to use for hobby projects or development, testing, things like that. The limit though is on the database size. So I have, what is it, 50,000 nodes and 175,000 relationships. So I have
exactly.
some limited resources on the size of the database.
But that's the only limitation, right? So in exchange of that, you get the full Neo4j Enterprise Edition running underneath the hood, basically. So you get all the features.
For sure. Okay, so while that is spinning up, we have the docs over here. Let's go over to VS Code, where I'm going to cheat. I wrote a little bit of code just to get us started, and I'll post all this up to GitHub later on, so you can see all this, and we'll drop that in the description. But this is better than watching me make a bunch of typos. So we'll have a pretty simple data model, and this is pretty much, if you look in the docs in the getting started section, yeah, here, let me drop that in the chat. I think I have the chat. Do I have the chat? Yeah, here we go. Yeah, so this is pretty much just the getting started example from the docs. So we write some type definitions. So we have movies. Movies have a title. We have actors. Actors have a name. And then movies are connected to actors with this acted in relationship. We add a relationship schema directive. So schema directives are these, like, I think of them as annotations in our GraphQL type definitions that define that there's some sort of custom logic that should happen. So schema directives are GraphQL's basically built-in extension mechanism. And so because we have a bit more information in the property graph data model that we use with Neo4j than what's just in the GraphQL data model, if you will, we encode that information with schema directives. So here we're saying this relationship from movie to actor, well, it's a relationship type that we need to store in the database. We'll call that acted in. And this allows us to adhere to the Neo4j conventions of like using all uppercase with underscores, whereas GraphQL field names, we're using camel case typically. And then every relationship in Neo4j has a direction, whereas GraphQL, we don't really have that concept of direction. Okay, so pretty simple data model. And then I've started a Node project here and installed some dependencies. So I've got the 3.0 version of Neo4j GraphQL and also the introspector, which is a separate package that allows us to generate these type definitions from a database. We'll take a look at that in a minute. I've got Apollo server here. So the Neo4j GraphQL library we can use with any JavaScript GraphQL implementation or JavaScript server. Apollo server just happens to be one that we really like. That's really easy to use. So I think probably the most common Node.js GraphQL server. Then we have the GraphQL package. This is the reference implementation that the GraphQL Foundation maintains. So we're pulling in the latest version of that. And then also the Neo4j JavaScript driver, which allows us to make a connection to the database. So those are the dependencies we installed. And then in our index.js, we've got some code here. So we're pulling in some packages here, like the Neo4j GraphQL class, Apollo server, and then some utility things. I'm reading our type definitions from this schema.graphql file. We're creating a driver connection to Neo4j. And then we create this instance of the Neo4j GraphQL class, where we're passing the type defs and our Neo4j driver instance. Then we grab the schema from this Neo4j GraphQL object and pass that to Apollo server to then start a GraphQL server. So if you've built GraphQL servers previously, you will have written resolver functions that can kind of be, honestly, kind of a drag to write resolver functions because it's a lot of kind of boilerplate logic for fetching data from a database. So resolver functions, this is where the logic for going out to the data layer, whatever it is, in this case, the Neo4j database, to resolve our GraphQL requests. So when I say create a movie, the resolver function has the logic for going out to the database, creating that node, similar for queries. So if you've built a GraphQL server before, you've probably spent a lot of time writing these resolver functions, which are just kind of a lot of, like boilerplate code for fetching data, creating data. So note that we didn't have to write any resolver functions. All that's handled by the Neo4j GraphQL library, which is super cool for us because it saves us a lot of time as a developer. I do, though, need to put in my Aura credentials. This is reading from environment variables. Let's be lazy and just paste that in from Aura. Here's the Aura console. So I need my connection URI for my Aura instance that I just created. And my password that, oh, did I save that? I hope so. I think I put it over here. Neo4j password. So I'll just put those in. Okay, and do node index.js, start our GraphQL server on localhost 4000. And this is Apollo Studio, specifically, what do they call this? Sandbox, I think. So previously, you may have seen GraphQL Playground or Graphical. Apollo Studio is just kind of the latest version of that now ships with Apollo Server by default. So it allows us to view the GraphQL schema, to write queries in the browser, kind of a testing and development environment. So we can look at.
Would that be the equivalent to Neo4j Desktop?
More like Neo4j browser, I guess.
Browser, sorry, I meant browser. Yeah, I was meaning to say browser. Yeah.
Yeah. So like with Neo4j browser, I can write Cypher queries and visualize the results with Studio, with Apollo Sandbox in Studio. Studio is like a larger Apollo project. Like I think Sandbox is specifically this piece. So here I'm writing GraphQL queries, visualize the results. I can look at the documentation, so I can see I've got, I can query, zoom in, make sure this is big enough. I know I've got kind of a wide screen here. But like I can search for movies by title, for example. And let's just leave this in the middle here. So here, oops, fat fingered that. There we go. Okay, so here we're searching for movies and their title, and I get back an empty array because I just created this database. There's nothing in it, but I can create some data. So to do that, we'll write a mutation. Let's say create movies, and that's going to take an input object. I'm going to use the inline. Where is that? There we go. Want to inline variables, just so I'm typing my variables up here. So input is an object. Let's add a title for the movie. We've got to do the matrix, right?
I think we have to, yeah.
If you work in Neo4j, that must be your favorite movie.
No other options allowed.
That's right. Okay, and then we also have, in addition to just creating the movie, we also want to create some actors connected to it. So let's create some actors. And here, this is really neat. So this is a feature called nested mutations. So in this mutation, I'm going to create the node that represents the movie The Matrix, but then I also have actors. And so in the same mutation operation, I also want to create actors, or if they already exist, create relationships that connect them. So I'm going to say, let's create actors. And again, let me zoom in here. Okay, so we're going to create the node, and we'll set the name field to Keanu. And then we need to return the movies that were created. So let's get title, and then actors, and then name. And now when we run this, we should get back, okay, cool. We have movies The Matrix, which is connected to Keanu Reeves. And if we go back now to Aura, so let's open up Neo4j browser for this Aura instance, and I need to find my password again. Here it is. And so now we can write a query that, let's just return everything. I should have two nodes, one node for our movie, The Matrix, that is connected to Keanu Reeves. Okay, cool. Let's do one more, and then I see some questions in there. So let's do one more, and then we'll answer some questions. So let's create another movie. I'm gonna commit some heresy here and admit that The Matrix is not my favorite movie. My favorite movie is my favorite movie is Point Break, which is another Keanu Reeves movie. So we're gonna do a create movies.
Well, that's close enough.
I mean, yeah, it's got Keanu, right? So, so I changed the title there to Point Break, but if I run this now, I'm gonna create a duplicate Keanu Reeves node, because I'm saying for the actors connected to Point Break, this is going to be a create node operation. But I don't want to do that because I want to create a duplicate. I know it exists, so let's do a connect where the node name is Keanu, and then I think I need just another curly brace there and a curly brace here. Yeah. Okay, so now we're saying create movies, create this movie, Point Break, and connect to an existing actor node where the name is Keanu Reeves. So we run that, and that's returning the movie we just created and the actor connected to. If we jump in now into Neo4j browser, we see, cool, we've got two movies, Point Break, Keanu Reeves, Matrix. There's one thing I want to do, and then take a look at the questions here. So what was going on behind the scenes was that when we sent a GraphQL request to our GraphQL API, the Neo4j GraphQL library was generating a single Cypher statement to do these operations. And we can actually see what that Cypher statement is by setting the debug environment variable. So this is in the docs. If we look at the troubleshooting section in the docs, there's a section here on debug logging. I'll drop that link in the chat. So if we set that, debug is Neo4j GraphQL, and then there's different level debug log levels. I want to do everything, index.js. Oh, forgot node. Node index.js. Okay, so now let's go back to Apollo Studio, and let's just write a query that says find all the movies and their title. And we can see in the log in the console here, this is the Cypher statement. Well, first, let's scroll back and see it says, hey, we've got an incoming GraphQL request. There's no variables. We don't have authorization enabled, so we're not seeing the authorization things. But if we did have authorization, we'd have like the decoded JSON web token, authorization roles, that kind of stuff. Here's the generated Cypher query. So match movies, return title. The generated Cypher query is, so this Cypher query might look a little bit different from maybe the way you would write this by hand. We're using a feature of Cypher called map projections that allows us to return what's basically a JSON object that we build up that matches the data expected from our GraphQL query. So if we had something more complex here, that's like, now let's find actors and their name as well, we'll see that now we have a bit more complex Cypher query. So now we've included the traversal for this, but that's done in the map projection, and it's using a feature called a pattern comprehension to actually do the traversal here. So what we're returning is an object with only the fields that are requested in the GraphQL selection set. The selection set, that's this nested piece of the GraphQL query here that is the fields that we want to return. So we're returning an object from our Cypher query that exactly matches what our GraphQL request is returning. So anyway, that's how we can see the Cypher statement that's being generated. So those nested mutation operations, we're still just generating a single Cypher statement to do that. Cool, so that's the basic features of the Neo4j GraphQL library. Actually, let's look at one more thing, and then I promise we'll get to the questions. One more thing I want to show here, and this is my favorite feature of the Neo4j GraphQL library, which is the Cypher schema directive. So let's take a look at the docs here. If we go to, where is this? Type definitions. And if we look for custom directives, we don't want custom directives. We just want Is it in types? No. Oh, Cypher directive. There it is. Staring at me right in the face. So the Cypher directive, this is super powerful. We saw an example of this just in the page earlier, where we can attach some custom logic to our schema. So let's add, how about a recommended field? Recommended. And this is a field on the movie type that's going to return a list of movies. So we'll say Cypher takes a single statement argument. And let's traverse from the movie node to, I guess in this case, we only have actors. Let's traverse from the movie node to actors that were acted in this movie to see what other movies they acted in, because that might be a good recommendation, right? So if I like a movie, if I like The Matrix, and I want a recommendation for another movie, well, what other movies are the actors from The Matrix in? Those might be good recommendations. So we'll say match this, and this is a GraphQL variable that's injected into the Cypher statement that represents the currently resolved object. So in this case, the movie that we're currently resolving. So we'll say, okay, who acted in this movie? That's going to be an actor node. And then what other movies did they act in? Those are going to be my recommendations. And we're going to return those. So we'll add that. I need to restart the GraphQL server to pick up our changes. We'll jump back to Apollo Studio. And now let's write a GraphQL query. So let's say movies, and we'll get title of the movie. Then we want the recommended field and the title, and let's get also the actors for that recommended. But let's filter here. Let's do a filter on this to search for, oops, let's get our inline variables. So it's a little more obvious what we're doing. So let's filter this where, how about the title of the movie is The Matrix? Okay, so this GraphQL query says, find the matrix, give me the title of the matrix, but then find recommended movies. So if I like the matrix, what are other movies that I might like? You can see in the result, if you like the matrix, recommended movie is Point Break because Keanu Reeves acted in both of those. And if we look at the generated Cypher, we can see, so here's the generated Cypher statement. We can see that our Cypher statement here, this is the statement that we annotated on the recommended field using the Cypher schema directive. That gets attached to the single generated query as like a subquery. So we're still just generating a single database query. That's really important for this N+1 query problem, which can come up a lot in the world of GraphQL. So we want to generate a single round trip to the database, which we're able to do here, and have custom logic. So I think that's really cool, super powerful. Okay, so that's sort of an overview.
Is that new with 3.0, or was this available before?
So everything we've talked about is not really new and specific to 3.0. The Cypher schema directive, that's something that was one of the fundamental building blocks, I think, of the Neo4j GraphQL integration. So there's been a few iterations of the GraphQL integration, and this has been kind of one of the core pieces of functionality that I think is really, really important, because it allows us to add custom logic, allows us to, if we wanted to, we can call Cypher procedures. So we can call out to like the graph data science procedure. We can use things from the APOC library. So one trick that I like to use here is oftentimes in a GraphQL API, I want to fetch data from multiple APIs, from multiple services, not just from the database. And we can use APOC load JSON or APOC load JSON params if I need to make a post request to call out to another API to fetch data. So I think in the the Graph Academy course for the GraphQL library, the example we use is for a delivery service. So if I'm delivering packages, I want to know the address of where I have to go, but I also want to know what the weather is for where I'm going, so I can, put on my snow tires, or I don't know, whatever. And so we call it to a weather service using this trick. But it's nice because we don't have to write a separate resolver function that calls out and handle the request and all of that stuff. We can just write Cypher to do that. So it's, in my mind, a huge productivity booster.
Absolutely, it's super cool, and it reminds me a little bit of the feature we have enabled in Bloom, where you can store your custom cipher towards a certain query. So I could imagine if you are developing something with GraphQL and you have your resident cipher expert who's providing you these cipher lines, but the other team is kind of working on the coding itself. They could then work hand in hand together and then say, okay, what kind of cipher statement would be best put in here, and they would provide that, and then the rest of the team can focus on developing.
That's a really good analogy. I hadn't thought of that before. So that those are called search phrases in Bloom, where whoever's sort of configuring Bloom. So if you're not familiar with Bloom, this is like a visualization tool targeted for folks who don't want to write Cypher but want to explore the graph. And yeah, so like whoever's configuring either the Bloom perspective, or in this case, whoever's building the GraphQL API can write some Cypher, and then that functionality is exposed to the end user. And in the case of Bloom, right, that's like an analyst type person who's just using that search phrase in GraphQL. It's just a field on the GraphQL schema. It's not exposed to the client that this is a special Cypher directive field. Yeah, that's a really good comparison. I like that. Cool. Should we take some questions here?
Yeah, I think that's a good idea. I think maybe we start with David, who was one of the first to ask a question. He was asking ability to view graph data returned from a GraphQL request like Bloom.
Yeah.
Can we do that?
So I looked at this in the live stream, and I think I wrote up a blog post about this. Yeah, here we go. So there's a recording of the live stream of this where we build a React application to build a graph visualization of GraphQL data. And this example is using data from Lobsters, which is like a news aggregator. And this is nice because I'll drop a link to this in the chat. This is nice because with GraphQL, we get back JSON data, and we know how to work with JSON data in a lot of different visualization tools. So this is using the React Force Graph library to just kind of pass that data through from our GraphQL request and create an interactive graph visualization. So that's one way to go. There's lots of different ways to approach this, but I thought that was a neat approach. So maybe take a look at that blog post. The code is linked there. It's part of a series on working with this Lobsters graph data, where we also look at using Next.js to create and deploy the GraphQL API, and then this GitHub Actions tool for setting up regular imports of this data into Aura, which I thought was a fun series. But yeah, maybe start with that post and see if that's helpful.
Okay, cool. The next question was from Tim, asking what's the best way to get started with GraphQL and Neo4j without using the JavaScript language. Is that possible at all?
Yeah, that's a common question that comes up. I mean, you can build a GraphQL API in lots of different languages. I think there's GraphQL server tooling in pretty much any backend language. But GraphQL grew out of the JavaScript ecosystem with the reference implementation. A lot of the tooling exists there in the JavaScript ecosystem first. So That was a lot of the reason for choosing to invest in a Node.js JavaScript specific package for the Neo4j GraphQL library. So I would say take a look at what's involved with using the Neo4j GraphQL library for building JavaScript GraphQL APIs, because most of what you're writing is GraphQL type definitions. You're basically controlling your entire GraphQL API through the type definitions, and the JavaScript aspect, I'm going to say, doesn't really matter that much. There's not a lot of like JavaScript that you're writing there. So there is no other official Neo4j GraphQL integration in another language. It is the Neo4j GraphQL library is a JavaScript language. You can of course use any of the like Neo4j language drivers to send queries to the database in GraphQL resolvers. You're not going to benefit from a lot of the built-in things in the Neo4j GraphQL library. So yeah, I would say if you're looking for another language, I would encourage you to kind of do a cost benefit analysis maybe of using JavaScript and the Neo4j GraphQL library to see kind of what you get for free. Potentially, I could see like maybe like a hosted service, right, where you're just given a GraphQL endpoint rather than having to manage the Node app yourself. That might be something that would make sense, but that's not sort of available right now. But yeah, I guess I would say think about your choice to use other languages and sort of what you get with the Neo4j GraphQL library. Maybe that's worth it. Maybe the JavaScript aspect doesn't really matter because again, you're mostly just writing GraphQL schema definition language.
Okay. One question from Pat about the requirements needed. So in regards to Neo4j community versus enterprise, what's needed to run GraphQL library and where can you run it?
Yeah, so the Neo4j GraphQL library is open source. Anyone can use it. It is generating Cypher that you then point at a Neo4j database. That can be Neo4j Aura, can be a local instance while you're running, can be a Neo4j instance that you're hosting in some other cloud service, wherever. And it doesn't need to be enterprise. You can use Community Edition, you can use Aura. I want to think if there's any enterprise specific features. So some things that are in enterprise that aren't in community are some of like the database authorization functionality that doesn't really come into play. Creating things like some of the way that you can create constraints, like constraints on multiple properties and node keys, that's not really an issue. So I don't think, someone can correct me if I'm wrong, but I don't think that there are any Neo4j Enterprise Edition features specifically that are exposed in the GraphQL library. So I think pretty much anything will work with Community Edition or Enterprise or any flavor of Neo4j, since we're going through Cypher. So yeah, I will make that statement. But yeah, there's nothing definitely comes to mind that you can't do with GraphQL. Yeah.
Okay. Okay. Cool. And then because it came up now for a second time is Python and Neo4j and GraphQL. Would that play well together? Would you see this to be a good idea to combine things? And is there a recommendation on how to make it work?
So there are a couple of like community maintained projects out there that look at replicating some of the functionality that's in the Neo4j GraphQL library. So the idea of translating Cypher or translating GraphQL to Cypher, augmenting a GraphQL schema with these things like arguments for filtering and these kind of things in different languages. There's one in Python that's out there. I'm not sure how feature complete it is. It's not something that has a Neo4j team working on it. So I think have a look at those, see what functionality there is implemented if that is interesting for you. And then again, you can always use the Neo4j language drivers or some of the like OGM functionality, like Py2Neo is a package for Python that has a OGM API for building database queries. You can always do that. The downside is you then need to implement those resolver functions that we talked about that has the logic for fetching data for each field on each type, which depends on what you're looking for. If you want more like fine-grained control over some of those things, or if you only are exposing a small piece of the database, your data model is not complex, maybe that makes sense. So it's something to think about.
Cool. Okay, I think that was all the questions that I see for now. Maybe one from me is what's your favorite new addition to the GraphQL library with version 3.0? What's getting you excited the most out of this release?
Yeah, let's talk about that. So let's talk about what is new in 3.0. So I'm gonna take a look at Daryl's blog post here because I think he does a really good job of covering sort of what's new and specifically what are maybe some of the breaking changes that are out there. So the first thing that Daryl talks about here, and this is I guess a larger theme of the 3.0 release, is better handling for relationships in the Neo4j GraphQL library. And so the first breaking change, I guess, to think about is that relationship fields in your type definitions need to think more about the nullability of these. So in GraphQL, we can have nullable fields, so fields that can resolve to nothing, or we can have say that they're required, so that any movie must have a title, and then the actors array must give us at least an empty array. So the exclamation in our type definitions, that means that this is a required non-nullable field. The exclamations are now required on these relationship fields resolved in the database. This doesn't mean that the relationship needs to exist. It just means that we're always going to get back at least an empty array. So previously, you could be kind of lazy like me. I think pretty much all of my code examples out there have nullable relationship fields. So that doesn't really make any sense though, because as kind of Daryl shows here, like in Neo4j, a relationship is always connected to two nodes. So that concept doesn't really make sense. You're always going to get back at least an empty array if there are no relationships. So that's one change, just sort of clarifying that.
And
also,
sorry, Will, but when you say breakable change, that means previously this was possible in 2.x, and now if you work with 3.0, you need to do this because otherwise it'll give you an error back.
Yeah, I think when the Neo4j GraphQL library parses your type defs, it'll give you a warning or an error that says, hey, this doesn't make sense. You need to think about how you're treating the nullability of your relationships.
Okay.
Continuing on this path of looking at handling relationships better, another feature is actually enforcing this idea of relationship cardinality. So here we're saying that this movie has a single director because director is not in square brackets. If it's in square brackets, that would mean that a movie can have 0, 1, or more directors. Now it's saying that a movie has a single director. And previously that was not enforced by the GraphQL layer. So you could, in the database, create multiple director relationships, but then that is then not consistent with your GraphQL type definition. So now this is enforced by the generated GraphQL queries, so that we're enforcing the correct cardinality here based on your type definitions. Another one is handling undirected relationships. So in the database, like every relationship has a direction. Cypher exposes the ability for us to just leave off the direction at query time, which allows us to kind of treat relationships as undirected. And now that functionality is available in the GraphQL library as well. So we can specify a direction at query time, or if you don't want the client to think about direction, we can specify a default direction on the relationship directive. And then we also have new relationship filters. So the, in this case, ones that are generated for the connection between movie and actors would be actors and actors not. Those I think were a bit confusing on what those actually meant. Does it mean like if I'm searching for movies connected to Keanu Reeves and I say actors named Keanu Reeves, does that mean that only Keanu Reeves is the only actor? Does it mean that like at least one actor must be Keanu? That was kind of not obvious what was being conveyed there. So there are some more clarifying relationship filters added for things like some and none. So some is what we would want if we were looking for Keanu Reeves, like at least one actor is Keanu Reeves. And there's some good examples in there as well. So you can see that there's a lot of functionality for handling relationships, relationship fields, more clarity around that, I guess. We also have query limit control. This is really nice because now this allows us to just in our GraphQL type definitions set a default maximum number of results to be returned. This is a really easy way for someone to sort of go to your API and just kind of write a query that returns like 100,000 results kind of unknowingly. And that's a lot of data for the client to deal with. So that could cause some problems. So now you can set a default limit on the server side as you're constructing your type definitions, so you don't sort of have that problem of unexpectedly sending too much information. So that's I think the biggest new thing. There's some other enhancements and bug fixes. One of the big things is that this release moves to the latest GraphQL reference implementation version. So it's currently 16 series. Previously, you had to use something from the 15 series of GraphQL, which was a little bit behind. So there's some internal restructuring there that now is up to date with the latest version of the GraphQL reference implementation. So that's probably, I think, one of the biggest things that, so to answer your question, Alex, this I think is really probably my thing that I'm most excited about, is just being able to use the latest and greatest GraphQL JS reference implementation now with the Neo4j GraphQL library. So that's a good one.
Super cool. Yeah, thank you, Will. I think that brings us basically to the end of today. I think. Thank you, Will, for taking us on a tour around the GraphQL library, and definitely showing even some a small hands-on session. So we get I think we got a good experience of what it is and what you can do, and I hope you enjoyed it and had a good time. As I said, if you now have questions, follow on. The comments are open either in the YouTube section or in our community forum or on Discord. If you are interested in learning more about GraphQL, we have a workshop coming up in March with actually Will as well. And I posted a link in chat now, so you can register for that. That's in 3 weeks' time. That's on the, let me quickly do the check. It's the 16th of March. So yeah, exactly 3 weeks. Exactly. Thank you, Will. Here it is. You can register for that and learn more in a little bit more in-depth session, 2 hours, about how to use GraphQL in a meaningful way. And yeah.
Sorry, this one will be fun because we're going to look at the full stack aspects. We're going to use Next.js, which is a full stack React framework, and deploy on Vercel to use with Aura. So you'll see kind of how all the pieces fit together. So I'm excited for this one.
Yeah, that's going to be good, and that's part of our training series. So if you are in any stage of Neo4j, there's a session starting from next week, basically intro, and then we go into Bloom, then we take the GraphQL session, and we finish off with data science. So go on our events page, neo4j.com/events. There you find all the trainings and the workshops that are coming up. Yeah, and with that, I think we're closing. Thank you for joining. Thank you for watching, definitely, and thank you for your questions in chat. Hope you will use GraphQL and use it for your projects. If you do, let us know. Share on Twitter or community Discord, wherever. Always interested to hear and see what you are doing, and maybe once you'll be you can join us here on the virtual stage and for a live stream and showcase your products and your GraphQL projects. That would be cool. So I'm always open for that. So hit me up if you are interested to share something nice. And then thank you for watching. Wish you a great day. Enjoy the time, and see you soon. And thank you, Will, especially for you joining.
Of course, yeah, for sure. And I think we didn't have enough time to dig into some of the more interesting features that are not specific to the 3.0 series that were released previously. So things like the introspector, working with indexes and constraints, aggregations. So I think maybe next week I'll do a stream that just dives into those, because I do want to dig into those. So I'll find a time next week and get that on the schedule to dig into those, because I think there's some really important, like really cool features that folks may have missed or are not aware of. So we'll set up a dedicated session for that next week and dig into those.
That sounds cool. Totally. Yeah. And it's always going to be available on demand. So yeah, that would be nice. Thank you, Will. Yeah. With that, thank you all for watching. Have a good time and see you soon.
Cheers,
Bye.
folks.